The 24th of January 2018 ESOA new national facility at ESO's La Silla Observatory has successfully made its first observations. The extra telescopes will search for and study Earth-sized planets orbiting nearby red dwarf stars. Extra's novel design allows for much improved sensitivity compared to previous searches. Astronomers now have a powerful new tool to help in the search for potentially habitable worlds. The extra telescopes are sited at ESO's La Silla Observatory in Chile. They will be used to search for and study Earth-sized planets orbiting nearby red dwarf stars. Extra's novel design allows for much improved sensitivity compared to previous searches. This nighttime view shows the three extra domes in the foreground and many of the other telescopes at ESO's La Silla Observatory behind. Courtesy ESO Emanuela Rumbo, the extra telescopes are sited at ESO's La Silla Observatory in Chile. They will be used to search for and study Earth-sized planets orbiting nearby red dwarf stars. Extra's novel design allows for much improved sensitivity compared to previous searches. This view shows one of the three extra in its dome. Courtesy ESA Peter Horolek, the extra telescopes are sited at ESO's La Silla Observatory in Chile. They will be used to search for and study Earth-sized planets orbiting nearby red dwarf stars. Extra's novel design allows for much improved sensitivity compared to previous searches. This view shows one of the three extra domes with its access door open. Courtesy ESA Peter Horolek, the newest addition to ESO's La Silla Observatory in northern Chile, exoplanets in transits and their atmospheres. Extra has made its first successful observations. Extra is designed to search for planets around nearby red dwarf stars and study their properties. Extra is a French project funded by the European Research Council and the French Agence Nationale de la Recherche. The telescopes will be operated remotely from Grenoble, France. To detect and study exoplanets, Extra uses three 0.6 meters telescopes. They regularly monitor the amount of light received from many red dwarf stars and look for a slight dip in brightness that could be caused by a planet passing, transients, across a star's disk and obscuring some of its light. La Silla was selected as the home of the telescopes because of the site's excellent atmospheric conditions, explains the project's lead researcher, Xavier Bonfils. The kind of light we are observing, near-infrared, is very easily absorbed by Earth's atmosphere, so we required the driest and darkest conditions possible. La Silla is a perfect match to our specifications. The transit method involves comparing the brightness of the star under study with other reference stars to spot tiny changes. However, from the ground it is difficult to make sufficiently precise measurements this way to detect small, Earth-sized planets. By using a novel approach that also incorporates information about the brightness of the stars in many different colors, however, Extra overcomes some of these limitations. The three extra telescopes collect light from the target star and four comparison stars, and that light is then fed through optical fibers into a multi-object spectrograph. This innovative approach of adding spectroscopic information to traditional photometry helps to mitigate the disruptive effect of Earth's atmosphere, as well as effects introduced by instruments and detectors, increasing the precision achievable. Because a transient's planet will block a greater proportion of the light from a smaller star, Extra will focus on targeting nearby examples of a specific kind of small, bright star known as M-dwarfs, which are common in the Milky Way. Such stars are expected to host many Earth-sized planets, making them prime targets for astronomers looking to discover and study distant worlds that could be amenable to life. The nearest star to the Sun, Proxima Centauri, is an M-dwarf and has been found to have an orbiting Earth-mass planet. Finding these previously undetectable Earth-like worlds is only one of two key objectives for Extra. The telescope will also study the planets it finds in some detail, for assessing their properties and deducing their composition to determine how similar to Earth they could be. With Extra, we can also address some fundamental questions about planets in our. We hope to explore how common these planets are, the behavior of multi-planet systems, and the sorts of environments that lead to their formation, adds team member José Manuel Almenara. Bonfils is excited for the future. With the next generation of telescopes, such as ESO's extremely large telescope, we may be able to study the atmospheres of exoplanets found by Extra to try to assess the viability of these worlds to support life as we know it. Study of exoplanets is bringing what was once science fiction into the world of science fact. About ESO. ESO is the foremost intergovernmental astronomy organization in Europe and the world's most productive ground-based astronomical observatory by far. It is supported by 16 countries: Austria, Belgium, Brazil, the Czech Republic, Denmark, France, Finland, Germany, Italy, the Netherlands, Poland, Portugal, Spain, Sweden, Switzerland and the United Kingdom, along with the host state of Chile, and by Australia as a strategic partner. ESO carries out an ambitious program focused on the design, construction, and operation of powerful ground-based observing facilities, enabling astronomers to make important scientific discoveries. ESO also plays a leading role in promoting and organizing cooperation in astronomical research. ESO operates 3 unique world-class observing sites in Chile: La Silla, Paranal and Chajnantor. At Paranal, ESO operates a very large telescope and its world-leading Very Large Telescope Interferometer, as well as 2 survey telescopes, VISTA working in the infrared and the Visible Light VLT survey telescope. ESO is also a major partner in 2 facilities on Chajnantor, Apex and ALMA, the largest astronomical project in existence, and on Cerro Amazones, close to Paranal. ESO is building the 39 meters extremely large telescope, the ELT, which will become the world's biggest eye on the sky.